All right, so we're going to just pick up where I'm currently at. For those of you that need to recap everything we talked about before, check out the old video. All right, so we wanted to pull out the third index. And so within this, we see Fred pops back out of there, right? So we could pull out those individual ones. If we have this entire list and say we put the 3 at the end, then we would get back elephant. Typically, the way you would use that is you would specify a variable name, then have some list to there, and then you would call back out the index that you actually wanted. All right. If we try to call something that doesn't exist, like what you saw before, you're going to get an index error. Does anybody remember what we can use to catch errors? We learned last week. Yes. Kind of, yes. Yep. We look for exceptions. So in this case, this is an exception. We would wrap this in a try and except, and that way we could catch specifically for index error. And if it's not an index error, we can use a blanket except and raise any kind of issues there. Great. Again, you guys want to know that stuff because it isn't just a quiz question. You'll need it for your midterm projects. All right. As you can see here, if we try to call something like 1, we'll get it back. If we try to use something like a float, we're going to get back and say that, it can't be a float. It has to be an integer or a slice. And we'll talk about slices here in a little bit. Like I said before, list can contain any type of variable inside of it or any data type inside of there. So for example, this contains a list with 2 lists inside of it. Therefore, we have the first list of cat, bat. We have a second list of 10, 20, 30, 40, 50. If we want to get back out this 30, for example, the first thing we do is go into our spam and we tell it which list we want to work with. So again, this would be in the 1 index of the outer list. So we put the 1 in here. And if we want to claim this particular section inside that list, we would then want to put 4 in order to get 50 out. We would use 3 if we wanted to get the 40 out. All right. Notice how these are kind of chained together. So as you get nested and you get lists inside of lists, you will want to call those out based on their index, starting with the outer one, moving their way in. All right. Indexes again start at 0, move all the way up to whatever the total length is. If you guys remember your length function that you used in the past, you can use that here in order to calculate the total number of items inside of your list. So if we use a len on my dogs and we decide to print that, you'll see we get back 4. So it tells us there's 4 items inside that list. Now, if we do a little bit of math and a little bit of programming, we can typically figure out the last one that we want to get, where we could calculate the total length, right? And always subtract 1 because we start at 0. So if I want to print len my dogs, in which case I may say something like my dogs, and I want the len of my dogs minus 1. And that will get me the last one in the list, right? Because I don't know how big this list is. So I calculate the length of this and I use minus 1, and that should give me the last one in the list. Let's see, len of my dogs. Yeah, actually, we need to put this in a parenthesis here. And it helps if I use this correct one. That's actually what was wrong. Okay, and you will see that we can get back Fred. So what this did was it calculated the total length of the list. We took 1 away from it, therefore we should get the last one in the list, and then we go ahead and have that print, right? That's a little complicated. So it turns out you can just use negative indexes. So if we start from the right and count backwards, we can use -1. So if I say my dogs -1 or -1, and then tell it to print that, we will get back Fred at the end. So you don't need to calculate this length and do all that. There's an ability built right into Python for you to grab the lightest one. If you want the second to the last one, you would use -2, and then you would have -3 and -4, which means that in this case, we'd look at this list. Cat is also equal to the 0 index. It's also equal to the what? -4 index. So each one of these is always going to have two values, depending on whether or not you're using the positives or the negatives coming out of there. All right. We go back and look at my list of dogs here. Say we want the first two out of there, and we want to put those into their own list. So we're going to call this the first two list. And in order to get those out of this particular one up here, we're going to say my dogs. We're going to start from the left, meaning we're going to start at 0. We'll use a colon, and we want to go up to, but not include this one Josie here, right? So we would use a 1, or I'm sorry, a 2, which would say, give me everything from 1 to 2, but not including 2. All right, this is one of those tricky ones where it goes up to, but not including. So if we do this, then if we take a look at first 2, you can see that we were able to slice out of this list the first 2 items that were in it. All right. So this here is known as a slice, where we give it the first value, which is where we start. The second one includes, but not, or goes up to, but does not include. All right. We can write that shorthand, meaning that we can take out the 0 and just use :2. It will do the same thing, where we will get back the same variable. All right. So whether you use that 0 in there or not, the key is that you have to have that :2 in order for that to work. We could also slice going backwards. So if we wanted to start at -1 and go to -3, that would give us what? What names should we get back? Fred and Josie, right? Anybody know why that didn't work? What happens if we flip this around? Now we got Beebs and Josie. What actually came back there? So -3 all the way to -1, but not including, right? So if you're going to use that in this fashion, it won't necessarily go that direction. So we wouldn't go something like this, but we could calculate from -3 going from left to right. Okay. You could also go all the way to the end if you wanted to. So if we did that, we would have something like -1 to say 0. And that should give us back the rest of the list. Actually go the other direction. So it'd be something like 0 to say -1, which would end up returning everybody except for Fred in this case, because we go up to -1, but do not include. So again, some of these you can use interchangeably, but the negatives can sometimes, you can't work backwards back to the left, right? All right. We talked about getting the length of the list using the len function. This is useful, particularly when you guys start doing variables. So if you start adding a bunch of things to your list, you need to calculate the total length or how many items are inside that list. You can use that len function to do that. All right. An example of that would be, say that you have 10 of these inside of our list here, right? Or in this case, we have 1, 2, 3, 4. Let's just throw a couple names in here. All right. So at least we have 6 now. What we could do is we could use the len of our my dogs, which would tell me the total length of that. And so therefore, say I wanted to say 4 dog in range of the length of my dog. Or maybe I wanted to do something like, let's pick a random one out of there. So if we go back to import random, like we done in the like we have done in assignment 2, you could then say something like random dog equals random dot randint, and we need to pick something starting from what? We could use 0 to 5. That's one way of doing that. What if we don't know the total length of my dogs? Yep. So instead of the 5, we could use the length of my dogs. But the problem is that's going to return a what? Exactly. We would need to calculate that with a -1 so that we could get the total length in there. There we go. And the idea is that that would give us a random dog. Then we could say my dogs and then pass in random dog in order to get that back. If we go ahead and print that, you can see that we get that. And if we run this, you'll see that it randomly picked Fred. And if we run it again, it randomly picked Sam. So the idea is that this randint is picking an index for us. We're going to start at 0. We're going to go up to the total length of this -1 so that we can get the last index of that. And then we can go ahead and pass that into the random number. So it's randomly passing us a number. We do print random dog, which is really just a random number. We can then see we got 5, which is going to give us back Jack. All right. We've talked about string concatenation and list replication, if you guys remember that. So string concatenation is where we took 2 strings and combined them together with the plus sign. We can do the same thing with the list. So if I want to take 1, 2, 3, and we want to put in a second list of A, B, C, we can use the string concatenation in order to get one long output of a list with those variables inside of it. We want to use replication, meaning that we have said list and we want to repeat that, say, 3 times. We can use the multiplication sign, asterisk, in order to repeat that 3 times all the way through. All right. If we already have a list that's assigned here, you can treat it just like you do with the string, where you can say then spam is now going to be plus ABC, and it's going to combine those together where spam equals both of those. All right. Does anybody have any questions on lists so far? Most of the time, you guys will be using lists in most of your projects. If you want to store multiple things, for example, you guys have had a program where you collect a name, you collect an age, you may have collected your brothers and sisters' ages and then calculated, who's older, who's not, that kind of thing. Lists are going to be able to store all that data in there. If you guys are coming from a computer science background, this is similar to arrays. All right. So we need to be able to work with a couple things inside of lists. And the first thing we want to do is potentially remove something from the list. All right. So I have my dogs here and say that Jack passes, right? We want to remove that from the list. So to do that, we have to know which one Jack is specifically. But we could say del, and then we're going to say my dogs. And in this case, we want to remove that 5th index, right? When I do that, I can then print my dogs, and I should be able to remove Jack from that list. All right. Say I don't want to remove Jack. Say that Fred passes. That would be which index? All right. And when I remove that, notice that it shifted everybody down. So Jack is no longer 5. He is now what? He's now the 4th index, right? Notice that Sam and Beebs ended up staying the same, as well as Josie, but Ben and Jack slided down. Okay. So we can use a delete statement in order to remove something from the list. However, we need to know exactly what index that's in. All right. There's a couple other ways of working with lists. So if we look at this one here where they're talking about working with it, we can have them enter the names of their cats, or in this case, like my dogs. We can enter those in, and then we can add those all to a list so that we can put them in there. Okay. So we could collect all this and have cat 1, cat 2, cat 3, cat 5, etc. What would be nice is just being able to take that in until they've listed all the cats that they have. So if we look at this code, we start off with cat names. We're going to put them in a while loop to ask them to enter in the name of the cat. All right. And we're going to append the name based on whatever the length of the cat name is, +1. And then we can enter in nothing, and that's going to break out of our while loop. In the meantime, we type in the name of the cat. We then set cat names is now equal to cat names plus whatever this list concatenating that we're putting in here, right? So this allows us to take the original list, and then we're going to concatenate a new list with the new name inside of it and just keep adding it all the way through. All right. At the end, this will end up allowing us to display all the cat names, and we can go through that. Okay. If we look through this, you can then enter in the names, and then it's going to spit out all those names. It's doing that by using a for loop. So for loops are the best way to go through a list. Why? Because the list has a finite number of indexes in it. Therefore, if we say for name and cat names, the first time name goes through there, it's going to take the 0 index. The next time it loops through, it's the 1, 2, 3, whatever's inside of that list. So anytime you want to print out a list, if you want to do that for troubleshooting, you can use something like this, where we print it out, and this is what comes out to the command line or out to the user. However, for your homework assignments, midterm projects, etc., we should never print a list out to the screen like this. Instead, we should do something like for dog in my dogs, print my dog. And at the bare minimum, this would print this in a nice, unique list going down. So it's my dogs. Nope. Typed in the wrong issue on my own. Let's go there. So for my dog and dogs, and then it prints them out in a nice clean line. It would be beneficial before this to print something out like these are my dogs. And now we have a nice clean display of what's going on inside there. All right. So in your command lines and in your projects, etc., homeworks, don't print lists out to the screen. You can do it while you're debugging. That's fine. But when you actually print them out to the users, this is how you should display all kind of lists. It's a very simple for loop to loop through there. All right. So we talked about that here. You can also use for I in range, which you've done in the past. You get 0, 1, 2, 3. If you note, when you do this, this could give you indexes. And therefore, by us putting in a list, essentially by using range 4, we are creating a list that goes from 0 to 3, right? Then we print I, we get each one of those out. In this case, if we want to print a range out of the len of the supplies, then it will actually allow us to enter in. Note what this code is doing. So we're taking supplies, and we have a list of those supplies. We say for I in the range of the len of supplies. So if we break that down, we're going to calculate the length of supplies. We're going to get a range of that. That's going to get us back I, which is going to be different every time we go through it. Essentially the index of whatever one of these are as they go through. Then we can use that index to print that out. So index 0 is pens, index 1 is staplers. Notice how this piece of our print statement is a variable that's automatically being assigned. And this piece of the statement is using that same I in order to look that up in supplies. Does everybody see how that can be beneficial? So instead of me listing out the dogs in this fashion, where we have Sam, Beeves, etc., going down, say I wanted to put numbers in front of those so that I could determine it's a numbered list. I would say for range in the len of my dogs, right? Then I can print something in a statement that would be something like print I plus Let's do something like a period and then throw a space after that and then plus whatever dog. Now, does anybody see what code this could have a problem with here? What's that? This is actually just going to calculate the total length. You're right. The number that we want to come back is a -1. Yep. Any other issues we see within the print statement? Let's actually, I use the word I instead of dog, so let's use I. And then inside of here, we don't want to have dog. We want to have something like my dogs. And this is I, right? So that we can get the index. What else is the issue inside this print statement? Yeah. Nope. What is I? What numbers were, or what comes back from I? If we do this, right, this range is going to end up giving us what back? It should give us back this, right? Where we would have something like a list with 0, 1, 2, 3 in it, right? What is 0, 1, 2, 3? What type of data? Integers, right? So if I try to run this screen, what's the problem with this print statement? Exactly. So I would have to convert to a string before I could use that inside of a print statement. All right. If I run this, we can now see that we get those numbers. Now, this works great, but now my list starts at 0, right? So in that case, instead of doing that, we would probably want to keep our existing outer list as the total length, which means we'll start at 1. In which case, we then want to come over here, and this is going to be the -1 so that we get that one out. Now, if we run this, it makes a little bit more sense, except we still start at 0. So where would we want to start our range? 1 comma, right? Taking it all the way up to the total length of my dogs. Now, if we run that, we're going to see some desired output down here where we have 0, 1, 2, 3, 4. Now, what's the problem with this one here? It's not picking up Jack. Why is it not picking up Jack? I have this -1, right? So we would take that -1 out. And now we've got Jack in there. But what happened? Now Sam's gone, right? So instead of doing -1, why don't we start at 0 and just say I plus 1? And by doing it that direction, now we're going to change the number that we're trying to change, but we don't mess with the index that's coming back out of this range. All right. So all we're doing is we're getting that I, which will be 0 because that's the range we wanted. We add 1 to it so that our list is nice and neat as it goes down. Anybody have any questions on this? So when you guys have a list and you want to kind of have them in a numbered order or whatever's coming through, we typically don't want to start lists with 0. We would want to start that with 1. And therefore, we would just add 1 to that initial setting, which would allow us to then output what's going through there. Now, the caveat is, say that I had something in a program here that said, pick one of my dogs, and then we put this list going out, right? And then if we wanted to print out more information about that dog, then we would just use whatever number they typed in, which then we could plug that into the index and get some information about that dog. The problem is the number they type in is not going to match the index. So we would either need to subtract 1 from whatever they type in, or we would have to do some other kind of function or write something else to make that in there. But it makes it more human readable. The cheating way would just be start at 0, take in whatever they got, and that becomes the index. It's not really cheating. It's just that's the simple way of doing it. However, we don't typically start lists at 0. Okay. Anybody have any questions? Are they able to follow along so far? And if not, now's the time to let me know. All right. We can also check to see if something is in a list. So for example, we can pass in the string howdy and see if it's in this list. If it is, we'll get back a true or a false. This is nice if we're going to do some kind of if statement, right? So say I have this code down here, which we're going to steal. We have a list of my pets of Zophie, Puka, and Fattail. We can then print, enter in a pet name. They type in a name, and we can check to see if that name is not in my pets. Then we can say, I don't have a pet named whatever they typed in. Else, we're going to head and enter in the name of the pet and say it's their pet. We would probably want to do something like this in a while true statement so that we can keep them in there indefinitely until they type something that is actually legitimate. For example, this one here, in which case we could use a what to get out of that while true. Break, right? So if we run this one, we can say enter in a name. I put in 0 Jack, says I don't have a pet name that. ASDF, don't have a pet name that. But if I go with Puka, I get a pet name. All right. If I run this and type in Puka, what's going to happen? Exactly. Remember, all variables are case sensitive as they come through there. Yeah. So we could add the lowercase Puka, but that'll probably throw off the total number of our animals and stuff like that. Yes, there is a way to get around that, and we'll get to that one. Yep, great question. All right. If we take in a bunch of names, so say we have cat, and then we have a list of all these cat attributes, right? You guys want to pay attention to this one. It is on a homework assignment or on a midterm, actually. If you have a cat and we have variable descriptors here, this first one is going to designate its size. So what we're going to do is assign the variable size to that 0 index. We're going to take their color as the second index and disposition as the third index. Notice I said third index, but not index 3, right? There's a difference. All right. We could do this, and it takes 4 lines of code, or in this case, 3 lines of code, because we're given this first line. If we wanted to write that same thing out, we could do that using what's called a multiple assignment trick, which allows us to say size, color, and disposition is equal to the cat. And the idea behind this one line of code is that it's going ahead and assigning these individual variables, right? Note that this number here is important because it determines which one you're connecting back up to. All right. If you try to use a variable that doesn't exist, for example, name, you're going to get back a value error, and it's going to say there's not enough values to unpack. We expected 4, but we only got 3. So you can use try and accepts in order to check that, but you need to make sure that you got the right variable inside of there. All right. If you'll remember back to this list that we were doing up here, where we were trying to print out the indexes. If I can find that code. Using the for loop. So we had index 0, then we had the pins and supplies. There's another way of doing that that's much, much easier, and it's called the enumerate function. And the idea behind the enumerate function is it allows us to use the multiple assignment trick. So what we do here is we have supplies, and we have this list of supplies. We're going to say for index comma item and enumerate supplies. The enumerate function is going to return what's called a tuple, and we'll cover tuples here in a little bit, but it's going to return a tuple. Looks a lot like a list. The idea is that the first one that comes back is going to be the index number of whatever variable that we're pulling out of our list, or item rather. And the second one is the actual item that comes back. So instead of having to write out all of the length or the function and the minus and then special print statements, we can simply say print the index and print the item out of here. And that will allow us to get the index number back and this one here. We could also still use the I in here, but this is a whole lot easier to get those two variables out of there without having to do those calculations down below. All right. So enumerate is very helpful when you're working with lists. It will return you back a small tuple, which would look something like this. So a tuple is going to be with a parenthesis as opposed to a squared off bracket. So you would have a parenthesis and it would have something like the index, and then say this one would be something like Zophie. Right? So if I told it to enumerate this list, the first time it came back, it would give us this, in which case we're using the multiple assignment trick to assign this as index, and we're going to assign this as our actual item so that we can use the word index and item inside of our print statement. Seems small and meaningless now, but when you get into really large lists, this is a whole lot better way of doing this with really short lines of code. 2 lines of code and it does everything for us. If you just need the actual item back, then you can just use a for loop and not have to use the enumerate function. However, if you want to utilize that index, it's nice to use the enumerate. All right. We talked about using random before so that we could pick a number out of here. Notice that we had to use multiple lines of code, right? So we imported random, then we used a random integer in order to calculate what random integer based on the total length of the items in there. Lots of extra code. Instead, we can just use something like import random. We get our list of pets as we see here. And we can simply use a random.choice and then pass it the list that it can go through, which is pets, and it will randomly pick one out of the list. No more figuring out the total length of the list and subtracting one and then setting up a random integer between this range and that range. Just use what's called random choice. So we can use the choice function of the random module in order to select one randomly. All right. We can also use one called shuffle, which a random.shuffle is going to randomly shuffle this group around. So the idea is that we can take a list, we get a bunch of things in. Yes, it's ordered, but we can shuffle a bunch of people around, then pick a random person inside of that. We have a better chance of getting more randomness out of our list. Anybody have any questions with the random module? So now you know ran int, and you also know ran choice and random shuffle. Choice is going to pick one out of it. Shuffle is going to shuffle the list around randomly. All right, we talked about this before where we have spam equal to 42. Normally, if we want to increment that by 1, we could use spam equals spam plus 1. That would give us 43 out, right? You can use what's called an augmented operator, which allows you to do spam equals 42, spam plus equals 1, which will then give you back 43. In other words, we take out the part that is spam plus here, and we just use plus equals on this side. Where people get this tripped up is they use equals plus. It will not do the same thing. All right. You got to have plus before the equal sign. But this is handy if you're writing really long variable names or a bunch of extra code. This is a great shorthand way of doing that. Yeah. It would take it, but it won't actually increment it. It would actually reassign it to 1. That's what it ends up doing. All right. You can do this with all of those. So you can use plus equals, minus equals, multiplication, division, modulus, etc. All right. This is also handy if you want to add things to a list or even to a string. So for example, if I have spam equals hello string, I say plus equals space world. I'm now going to get hello world inside of here. This is a great way if you're trying to build out a long string that you can plus equals things coming off of that. Which means if I wanted to have a list of all these coming out of here, right? And I wanted to print these out to the screen, we know that I could use print pets. And we would run that. However, that puts the brackets in there. We should not have output for that. What would be another way of doing it? We could use for pets and pets, print the pet. This would print it out nice and clean. But say we wanted to put these out each on their own line. We could use something like my pets equals an empty string. And then we could say for pet in pets. We could say my pets plus equals the pet. In which case, when we then print out my pets, we'll end up putting them all on the same line, right? So the first time it comes out, we have dog. Second time is cat, moose. Then this one, this is coming out from this original print up here. You'll notice the last one ends up putting them all together. Say we wanted those commas separated. What could we do up here? You could say something like pet plus, and then here we would use a comma. Then we could use run. And now it goes ahead and puts a comma separated in there. Problem is it ends with a comma at the end, right? And it might be nice if we actually used a space so that we could actually see what comes out of here. So now we have dog, cat, moose inside of there. Does anybody know of another way that we could pass these in? Yep. So if we have 4 pets inside of here, it would be something more like my pets equals, or in this case, we could do plus equals something like my pet, or in this case, what do we got? Pets. And we could add 0. And then we could use this as a string that would have something like plus, comma, space. Is that what you're saying? And then do one for each one of those. We could do that. So, whoops, too many of those. You'd have a 1 and a 2, right? We wouldn't want this last one in here. Then if we print my pets, we would have something like that on the output. Like you said, it's not efficient, but you have the right idea. There's something that we could probably do here in order to determine whether or not this last one is the last one, right? So how could we do that? You could. Remember that we have that enumerate thing that we talked about before, right? So if we say for index, comma, pet in my pets, in this case, we would use enumerate pets. Then we could say something like if index is equal to what? That might be a little more complicated because we don't know what the last index is. What if we say if pet is equal to pets minus 1? Now we know we're at the last one, right? Then we could say my pets. We still need my pets up here as an empty string. Plus equals the pet, right? Else, we're going to say my pets plus equals the pet plus the string space comma, all right? Or comma space rather. Then at the end, we can print that out. And you'll notice that we actually get the output we're looking for. So this little section here is going to chase that. Now, do we need to use enumerate? Really don't, right? Because we're not actually using index. So we could just say for pet in pets and get rid of the whole index. What this is doing is looping through the pets. It's going to check to see if pet, whatever one that we're at, is the last one in the list. If it is, then don't add the comma after it. For any of the others, we're going to go ahead and add the comma and the space. Therefore, when we print it out, we can get that output here. All right. Now, when we talked about this random module, remember that random.choice, random is a module, choice is a function, okay? We have the ability to use methods. Methods are done off of an actual variable. So if you call a variable dot something, that is a method. So if we have this list with hello going through here, right? So we have all these different kinds of hello. If we say spam.index, this dot index is a method. And in this case, this index method, we pass it in which item that we want the index back for. So if we want to figure out which one of these is hello, because we don't see it, right, as an end user, we could use dot index and it would return back the 0 for us. If we use chaos, it's going to return back the 3. If we try to return one back that is not in the list, we're going to get a value error that says it's not in the list. So it'd be a good idea to wrap using index instead of a what? Lady in the green sweater over there knows the answer. She said it earlier. Try and accept statements. All right. Forgive me. I'm horrible with names when I don't actually hear anybody's name as we go through here. All right. Index will allow us to get that index back out of there. Right now, when we wanted to add something to the list, we're going to use the append method. All right. So if we have this list and we want to append or add something to it, what you guys saw before was this whole augmented operator thing. That's not the best way to go about it. We can use the append method in order to add something in. So if we want to add moose to this list, we can use spam.append, and then we'd say moose. It will actually add it up to the list, and then we have it added to the very end. Notice because we use append, it puts it at the end. If we want to put it in a specific spot up here, then we will use the insert method. And the insert method requires 2 inputs. The first one is what index we want to put it at. The second one is the actual variable that we want to add in there. So in this case, if we have cat, dog, bat, we say the 1 index. This should move what? Dog, right? We're going to put it right inside of here. And we're going to add chicken so that we end up with this list inside of here. So you guys now know 3 different methods for a list. You have the index method, which will tell us back what number we want, or in this case, what index a particular item is at. We have the append so that we can add something to a list. And we have the insert so that we can add it in a very specific point. All right. If we want to remove values, before we showed you using the delete method, right? What was the problem with the delete method? We had to know the index, right? So the idea is that we would have to come up here and use the dot index method, figure out what that number is, then use the delete statement in order to delete whatever's at that index. Instead, if we know what the value we want to delete is, we can use the dot remove, and it will go ahead and remove that from the list. So you use delete if you know the index. You use a dot remove method if you know what the value is you want to remove. All right. If you want to sort everything inside of a list, say we have these numbers, for example, we have 2, 5, 3.14, 1, and -7. We would just call dot sort method on the list. All right. We don't need to say spam equals spam dot sort. That won't work. We just say spam dot sort, and it will actually calculate from left to right going up in order. All right. If we do this with a bunch of words inside of here, it's going to calculate based on A through Z. If we want the reverse of this, then we can actually use the keyword reverse equals true, in which case it will go from back to the end, or back to the start, rather. All right. These are handy when you guys want to sort different things out. When we get to homework assignment 3, you're going to want to know how to do that kind of stuff. If you have a mix of integers and strings, you cannot use dot sort. Dot sort doesn't know how to calculate that. So it only works if all the values are of the same type. So if they're all strings, if they're all integers, even if they're all floats, that's fine. It can be a mix of what? Integers and floats, right? It will be able to calculate those. All right. By default, when you run dot sort, for example, say we have capital Alice, then ants, then Bobs, then Badgers, and Carol, and Gats. If we do a dot sort, it's going to calculate all the capital ones first, then it's going to calculate the lowercase ones. All right. If we want to sort that by a specific key, we could use something like key equals string dot lower. So str means string. We're going to use the dot lower method in order to calculate the lower ones first, which would then output all the lowercase, then the uppercase version of what it is, then the lowercase, then the uppercase. Note the difference here is this did all the uppercase together, then all the lowers. This one's going to do the lowercase, then the capital version of that same one. Therefore, this overall is still A to Z. The only difference is now we're going to do the lowercase a's, then the uppercase a's. Anybody have any questions on this? No. Nope. You can use it if it's all integers. You can use it if it's all floats. You can use it if it's all strings, but you can't use it if it has strings and integers in there. The only combination one you can use is integers and floats. Yes. For what now? It's a good question. Does anybody know how we could go about sorting this? Granted, it's already kind of sorted. The best way I can think of is we would probably want to pull all of our integers into a single list, pull all of our strings into another list, sort each one of those, then use what to combine those? List concatenation, right? Then you can concatenate those back together. At this point, that's the most efficient way. Yep. If it was just letters in here, there's some wonky stuff that we can do, and I can show you that. It'll show up later in this semester. But for now, that's probably the best way. Split it, in which case you would just do a for loop going through this list. You would try to see if it's an integer. If it's an integer, add it to one list. If it's not an integer, it's a string, then go the other direction. All you have to do is just pass it the value and see if it comes back with a true false, right? All right. There is a way that you can quickly get the sorted where it's all strings and you want the reverse of it. You can use dot reverse. All right. They just added this. In the past, you had to use dot sort, say reverse equals true. There is a way that you can use dot reverse on this now. Anybody have any questions on this so far? All right. So if we go back to my list here, we can see that I have dog, cat, and moose. This is okay, but if my list gets really long, let's do something like this. Now you can see it kind of runs off to the right, right? Then I have to come back down here and skin it on the best. The best way to do this is if you click before this one and hit enter, notice that idle will actually align these all in the order as they come down. And so you can do this in this fashion. You can either leave this one at the end or you can put it down at the end. Okay. The benefit of doing this is it's really nice and easy to see inside your code. Technically, you don't want your code to be wider than 80 characters wide. It can go wider than that. Obviously, as you saw, it just scrolls off to the right. We would like to keep that clean so that we can see it. So it's best to go ahead and put each one of these on their own line if it is a very long list. It's also nice because you can then use inline comments over here. And we can say my favorite. And then maybe on this one, you have something else inside of here, right? We can put comments for each one of these as we're coming through. Where that may be beneficial is we could say something like, this is Jason. This is 6. This is Blue. We can say something that these are going to be something like the name. This would be something like height. And, you know, et cetera. So you can put comments so you can keep track of what those actually meant. Okay. This indentation matters. If I have this tabbed over, it's going to break my program. All right. It needs to be all in the same line or block of indentation. So that's what this is kind of taking you through, that you'll have some indentation issues when you go through there. Okay. That's going to be a good stopping spot for today before we get through the rest of these. Does anybody have any questions inside here? Whoops, sorry, somebody did ask one. Something with link -1 so that, yeah. Sorry, I didn't see that before there. But you are correct. In this case, we did the equals to equals. Yep. All right. So when we start off, I encourage you to go do this Magic 8-Ball program. Test it out. If you're struggling with this, play with this before we come to class Wednesday, as this one's going to help you get to the right end when you go through there. All right. When we get back, we're going to start on this sequence data types and we'll go from there. All right.